Hello and welcome to our training video today that will cover the history and use of the IFR 1200S communication service monitor. Let's talk about what the IFR 1200S is. The IFR 1200S is a communication service monitor, a very versatile piece of test equipment that upon its entry into the two-way radio field in the mid to late 80s replaced about 20 different pieces of test equipment that was required to service most two-way radios, pagers, and mobile phones, and other related equipment associated with the RF communication industry. Although there were other types of communication service monitors on the market, the IFR offered options that were standard equipment that others charged more for. One particular option was that of a lighter weight service monitor than the others were. The IFR came in a smaller, rugged designed case, most which included a battery so it could be used in the field when no electricity was available, and a soft padded case for protection while transporting. Let us examine what's required for a quality communication service monitor for a technician's workbench or for the service vehicle. A quality communication service monitor should have each of the following. It should be able to test RF equipment in a frequency range of 0 to 999 megahertz. At the time that this particular device came out, that's what was available. A spectrum analyzer, a signal generator, a frequency counter, an oscilloscope, a tone generator, a synad meter, a modulation meter, a tracking generator, a duplex generate and monitor mode, a watt meter, an RF dummy load, a DTMF generator monitor, paging tone monitor and generator, ports for over-the-air monitoring, external ports for in and out audio, test cables for RF use, test cables for oscilloscope use. It should be totally transistorized, in other words, no tubes, like the earlier models were. And on top of that, it should have a heavy-duty power plug and power supply. As one can see, a communication service monitor replaces many pieces of equipment that the tech was required to have on his or her service bench or in the service vehicle. Many of the required test equipment before the communication service monitor were tube operated, which meant that the tech had to wait for warm-up and stability to occur before use, a problem when in cold weather and out in the service vehicle. Just imagine, if you will, having to take that many pieces of equipment into a tire site or up 30 flights of stairs to the top of a building where the repeaters and antennas and other related equipment. Most communication service monitors of the time sold new for $10,000 or more. Sounds high? Yes, it does. But just figure up the cost of the individual equipment plus the repairs if you dropped one, and then that cost doesn't sound as bad. There were cheaper versions of service monitors, but most of them were not of the quality and caliber that an IFR was. Testing or servicing the transceiver of a two-way radio, mobile phone, tone DC remote, or paging encoder could be done after proper hookup of test cables from the transmitter or transceiver to the IFR 1200S. A tech should be able to observe the RF power output, on frequency settings, frequency deviation, modulation deviation, PL, DCS tone frequency and levels, DTMF frequencies and levels, and spectrum efficiency of the transmitter by monitoring the spectrum analyzer. In other words, when in transmit mode, the spurious harmonics exist. In addition, checking any voltage levels and or tracing of voltages, such as RF, AC, or DC, of or within the transceiver section. In addition, it should be able to help you tune and check the efficiency of a duplexer. After proper hookup of test cables from the receiver to the IFR, tech should be able to observe the receiver sensitivity and selectivity signal levels, on frequency settings, frequency deviation, modulation deviation levels of the receiver, proper decoding of the PL/DCS or multi-tone paging tone frequencies for both mobiles and pagers, DTMF frequencies through the receiver, and spectrum efficiency of the receiver, wide or narrow band signals. And again, plus checking any voltage levels and or tracing of voltages within the receiver section. Now let us look at each of the control functions, ports, and accessories of the IFR 1200S so it'll give you a better idea of what you'll be working with. Looking at the front of the IFR 1200S, starting from left to right, top to bottom, we have an oscilloscope, antenna port, frequency meter, volume and squelch knob for adjusting volume and squelch out of the receiver and out the speaker, an audio and RF watt meter. Just below those we have a lock lamp, which you see red. It stays on steady. That means the unit's in lockup mode and ready to be used. Receiver frequency shift knob, which we'll get into here on the second video when tuning a receiver. A frequency era selection knob. A mode selector knob between selecting generate, receive, duplex, or duplex generate. A modulation selection knob for selecting between AM at single sideband, FM, narrow, mid, and wide range, or normal modulation. And of course, an RF and modulation meter. The RF meter is the portion of the dummy load when the RF comes into the unit. Will tell you how much wattage your unit's putting out. Next down the face is a vertical, horizontal position for your oscilloscope, intensity level of your screen, and focus of that signal. As you can see, it changes while I move it. A DTMF function selection pad, a receiver variactor levels, a display that shows what the monitor is either set in generate mode, what its frequency or tone, or DTMF inputs, offsets, and other various functions that you're allowed to use. Next down we have a power switch between power, off, battery. When hooked up and available, we use power switch all the time instead of battery. Next in line is an AC ground or DC ground selection for your oscilloscope, a microphone input for testing over the ear, a tone output in case you want to run the PL or DCS or audio tone out for another device, DMOD input, external mod synad meter input, a duplex connector for duplex generate or the measuring of duplex RF. Now let's talk about some certain deals here before powering up one of these IFRs that you need to be aware of. First off, never plug this unit into a portable generator unless you know for a fact that the generator is a full sine wave producing generator. Doing so can short out the internal power supply board. Very expensive. Always make sure that when using shore power, house current, in the shop, out in the field, or somebody has a temporary power pole, that there is a three-pronged socket in which to plug into and that the earth ground is properly grounded. This can be done with an ohm meter measuring from the round earth ground hole in the socket to a metal pipe or some form of earth-grounded pipe. If in doubt, don't plug it into an AC socket, especially if using it at a remote site. And of course, if in America, make sure the wall socket you use is 120 volt AC and not a 220 volt AC socket. When using this IFR 1200S as a dummy load, to test the transmitter, make sure that you do not key the microphone or cause the transmitter to go into transmit mode when you have selected the generate mode to check the receiver. Doing so can blow the IFR's 1200S RF dump load resistor, which becomes very expensive. In other words, if you put it in generate mode and key that radio up, you blow that RF dump load resistor. You got to tear this whole thing apart and replace that resistor, if that's the only thing it took out. Next is the antenna port. Normally used for external antenna, also used for when testing duplexers. Never ever allow more than 1/8 of a watt of RF enter this port. The red tag says 1/4 watt, but if you set your mind and learn and accept the fact to 1/8 of a watt, you're likely not to damage this module. The duplex port, normally used for tuning duplexers, the same thing goes for the RF wattage on this port, no more than 1/8 of a watt. Even though it says 1/4 watt, just don't do it if you want your service monitor to give you years of service without forced repair. Volume control. Always check that the volume control is in its lowest position, fully counterclockwise, before powering the unit on. Setting it too high can blow that speaker out on that side. Squelch control knob. Check that this control is set approximately 1/2 a turn to an 1/8 of a turn to 1/2 a turn from the most left position. This will help in keeping the noise blast from blowing the speaker upon powering up. The tech can always adjust this control once the unit is powered up and stable. As you can see here, I turn the volume up, I can turn the squelch down just like on a regular radio. I can squelch it all the way out where it won't receive anything, or open up the squelch. Now just imagine if you turn that unit on and this thing was turned all the way up, what it could do to that speaker. Meters. These are analog style meters, and being so are very sensitive to hard pings on either side of the scale, especially when wideband and or on a FM radio channel, like a music channel. As you can see here, there's no signal, but the squelch is wide open. You can see how it's pegged to one side. A constant pegging can knock that meter out. FM radio channels, like music channels, can cause the frequency and modulation meter to pound itself if the control settings for each are not set properly. Touchpad. Very important to remember. This touchpad does not require a lot of finger pressure to push on the buttons. Just barely touch it, and you can see it changed. I've seen people take and slap those things like a computer keyboard. Makes me want to reach across and slap them. Use a light touch when selecting one of the touchpad numbers or selection. But most of all, always make sure your fingers are clean. I can't tell you how many IFR service monitors I've seen that this whole area is black. And that comes from people failing to wash their hands before using it. Been out working on their car, come in and test the radio out, and got grease all over it, dirt. It's just nasty. Nobody likes to walk in and use a piece of service equipment that's nasty and dirty. So always make sure your hands are clean. This completes video 1 portion of these videos. Video 2 will cover tuning your radio, and video 3 hopefully will cover tuning a duplexer. I hope this gives you an insight to what the 1200S communication service monitor is, what advantage it offers the technician, not only in the shop but out in the field, and how thankful we are today that we have such a service monitor without having to load up 20 to 30 different pieces of equipment that were tube operated. Thank you for watching. Hit the like button and subscribe if you wish. Feel free to leave any comments or questions you have at the bottom, and look forward to our second video. Thank you and have a good day.